Asked from a student yesterday about chapter 1 problem 19, and so I thought everyone probably could benefit from some discussion on this problem. So what we have here are two linear functions, one describing the supply curve of a product and one describing the demand curve of a product. So what the supply and demand curve measure respectively is how much of these video game consoles people are willing to buy at a given price points, that's the demand curve, and how much of this product producers are willing to create or supply at a given price point. So for example, at $600 per unit, suppliers are willing to make about a little under 2,000 of these units, but people are willing to buy about 2,200 of these units. And so we have some discrepancy there. And so the first question here is, if the selling price of an item is higher than it should be, the consumer demand for the item will what? And the producer's willingness to supply it will what? Well, if you make the price of an item too high, the higher you make the price, the less the demand for it there is. And that makes sense, right? The more expensive something is, the less people will want to buy it. So as the price is too high, the demand should go down. But the more expensive you make something, the more people are willing to sell it. People might not be excited about selling something for $300, but they will be excited about selling it for $1,000. So the willingness to supply that increases. And you can see that from the curvature of the graphs as well, right? This curve is sloping upwards, it's increasing. This is sloping downwards, it's decreasing. All right, great. So part B is the heart and soul of this problem. It's where the bulk of the difficulty and work comes in. So in the interest of time, I'm going to stop the video after I do part B. Once you have part B done, the rest of the parts more or less solve themselves. If you have more questions about it or you have follow-up questions, you can feel free to let me know and I'll do some more work with it. But for now, we just want to find the formula for these two lines. So normally one would do this on a paper and pencil, but because I'm screencasting, I'm going to use Desmos here to illustrate it. And the first thing I'm going to do is I'm going to set the screen here to look like the screen here. So 0 to 1,000 for X, 0 to about 5,000, maybe 5,500 for Y. Zoom out a little bit. Alright. So let's do these curves one at a time. The first curve is S of P. Which we know, because it's a linear equation, has to form MP plus B. Now, I don't know what M is and I don't know what B is, and Desmos doesn't either, so it's giving us these questions here, but let's ignore that and let's just use these as placeholders. So the first thing to note that the B of a linear function is the y-intercept. It's where on the y-axis, at what height does the line intersect that axis. So if we look at this, or better yet, let's blow this out, we notice that the S of P hits the axis at the origin, at 0, 0, or height 0. And that makes sense, right? If your product is free, no one wants to sell it. So that tells us that the intercept here is 0. Another way we could think about this is when your price is P, whatever your slope is, M times 0 is 0 plus, and that B has to be 0 in order for the S of P to be 0. So in any case, the y-intercept is 0. How do we find the slope then? Well, the slope is how far things go up as you go forward. So I can pick any point here, but why don't I just look at this? When I increase the price by 100, the number of copies that people are willing to sell of this stuff is 300. So when I go forward by 100, I go up by 300. That means when I go forward by 1, I'm going up by 3. To see it algebraically, right, my change in Q divided by my change in P is 300 over 100, in other words 3. So if I graph my supply curve, I get something like that. 3P plus 0. And that more or less looks like the curve that we were working with, right? Now, let's take a look at the demand curve. So the demand curve is going to be something much the same, right? It's going to be some slope P plus B because it's a linear function. So just like before, because we have this graphical representation, we should take a look at what our y-intercept is. So it's like, all right, when the price is 0, people are willing to buy 5, and then 51, 52, 5,300. Units of this stuff, and that's just from reading off this graph here. And our reasoning is the same. That's where this curve intersects the y-axis. And also, if I evaluate this function at p equals 0, I do get 5,300, which is this height here. Then to find the slope of this function, we know that our slope has to be negative, because as we increase p, our q values drop, right? So when p is 100, we notice that our q value is 4,800, right? So my change in q is 4,800 minus the initial 5,300 over 100 minus 0, and that gives me a slope of -5. And really, we could have used any point on this line to have done this, but it's just easiest to read off of this one. And so with a slope of -5, I can plot that there, and I have my supply and demand curves that look just like my supply and demand curves. So I believe that this is my solution. And so if I go ahead and put in my solutions that I just got here, I do believe that this will be correct. All right. Now, I'm not going to go through the details of all of the remaining problems, but I do want to show you a trick about how to now use these functions once you got them set up like this. If, like for example in part C, I want to know, well, how much is supplied and how much is demanded when the price is $400, what I'm really caring about is the, let's say some price $400, what I'm really caring about is, all right, what's my supply at that point? And what's my demand at that point? I'm going to change this to be green just to match the color. And so we can see here at $400, 3,300 units are demanded, 1,200 is supplied. And what I can do now is, if I want to know about any other price point, I could just change what A is. It'll tell me how much is supplied, how much is demanded. That's equivalent to plugging those numbers in for P, but I'm too lazy for that. Since I've already done this work, I may as well just let the computer do that part for me. And if I wanted to enter in a specific number, I can go ahead and punch that in, and it'll give it to me here. So hopefully that's helpful. Like I said, if you have any other questions about this, please let me know. Thank you very much for watching.